let's talk about the first couple chapters in your book. So in the original early days, like the 1990s, the web was like broadcast television. You would just put up a web page that would have things like images and text, and people would just view it, and that was all. It was one way. The web designer would put up the page and people would just view it. But then we moved to Web 2, where people interact with pages. You buy things, you post things on Facebook, you add content to the page with social networks, Facebook and Twitter and all that jazz, and online banking. So now your web page has programs on it, and those programs are receiving data that came from the user. And the problem is the user can send any kind of data up. And it turns out that the user can send malicious data, which confuses your program and causes them to do the wrong thing, and that's how web hacking works. So, like I say, the early static Web 1.0 would just have pages sitting there, and you could attack the web server itself or the operating system itself, and there were attacks like a directory traversal attack where you would just change the URL to point to a directory to a different location on the server, and that worked in very early versions of web servers. But you couldn't do much because it didn't have a login, it didn't have much content to steal, but modern web apps like Amazon and Wikipedia and others are two-way. Users are logging in, submitting content, posting things, and it's taking a bunch of cookies from your machine to identify you and dynamically generating content that's different for every user. Every person that goes to Amazon sees a different page with different prices, by the way. There are various tricks to try to get your products cheaper. People develop apps in-house by programmers that are often not trained in security, almost always not trained in security. Most development programs do not teach developers how to write secure code. This is a huge problem in the business, and I'm actually working with major corporations now. I do consulting, and I'm teaching secure coding to developers because in general this has not been done, and it's a relatively new thing. And if you take most programming certificates, you will not learn to write secure code. You'll learn to write the same broken stuff that everybody else is writing. So as you know, everything's out there. You can shop, social network, bank, web search, gambling, everything is out there. And all these things rely on taking data from users. Then you've got internal web apps used inside companies for their human resources, to control their servers and workstations, SharePoint to share data in Microsoft environments, their enterprise resource planning, Outlook Web Access to handle internal company email. That's a huge one. People keep hacking OWA portals and getting into company email. This is one of the most large, costly hacks right now is business email compromise. They hack your Exchange server or your OWA server or something, getting your enterprise email. Then they send emails that appear to come from the CEO saying, oh, send this money to this address or something. And people just send them money because their internal processes are not good enough to detect that. And then, of course, shared apps like Office 365 and so on. So web apps are extremely popular. Where everybody talks about the cloud. Putting whatever you do at your company in the cloud, like Amazon cloud, is usually enormously beneficial because all your workers are traveling and they're in a home for the pandemic and they're on business trips, and now they can connect from anywhere to your stuff, but so can all the hackers. So anyway, that's the thing here. HTTP is the protocol being used for all this. HTTP is what runs the web, and it was never designed to do any of this. The original purpose of HTTP was for Web 1.0. It was just to have static pages that were delivered to people that wanted to see them. And then patches were added, like cookies, to make it possible to do more complicated things. But fundamentally, it was not designed for the purpose it's being used for, and that's another reason why there are so many security flaws, and we'll see. All right. So web app security, we all know people get hacked right and left. Everybody gets hacked, even the strongest people. The NSA, Google, Yahoo, Amazon, everybody gets hacked, eBay. So nobody can really effectively protect their networks. It's very much a problem. And it's improving gradually, but, well, I feel like it's improving because people are getting much more clever about it, but I think the actual monetary value of hacks keeps increasing every year. So maybe I shouldn't say it's improving. The security is getting stronger, but the attackers are getting stronger too. So that's why there's a huge market for security professionals. And so learning to be a security professional is a very good career move. It looks like there's going to be no slowdown in security jobs anytime soon because we're so useless and ineffective. You hire security people, you get hacked, then you hire more security people. You can't buy anything that will really protect you. This fools a lot of people. Australia, about 5 years ago, the Prime Minister of Australia said, I've had it. I'm going to block all the bad things on the web. We're going to put up something that will block all the pornography, all the malware, and all the fraud on the internet and make a nice clean internet for people. And all the technical people said, that would be great, but there's nothing you can buy that will do that. There's nothing you can build that will do that. And they spent years trying to do it and millions of dollars and finally gave up and admitted that can't be done. Iran got so tired of us hacking them, they said they were going to withdraw from the internet and make their own private halal internet that would be clean and not have any of all this horrible stuff. And I think they still haven't done it. I'm not sure. The only people that have done it is North Korea, where almost nobody can get on the internet. There is nothing you can buy that will make you very safe. But there are things you can do to be safer than other people, and that's what we're going to do here. So often people attack your server and steal the data, and often they find ways to shut down your server with denial of service attacks. Yeah?
I'm curious, what was the workaround for Australia? They were trying to create the system where you block everything.
Well, the Prime Minister promised that as like a campaign promise, and then he paid people money who said they were going to do it, and they tried to build it with proxy servers and firewalls, and it failed, which is what you'd figure. All you get is fraudulent people that will lie to you.
China has a big firewall.
Yes, China has a firewall. It's very strong. I've been to China, and it's hard to get out through their firewall. It learns, too. I would set up a VPN. It would work. I'd walk to the next room. In 5 minutes, it's blocked because it's got AI. It learns. And yes, and it's pretty effective. It's not 100% effective, but I think that firewall is a whole army of people filtering the content. It's not just a device you can buy. It's a whole bunch of people filtering content and manually removing stuff. So, I mean, if you were willing to hire like 1,000 people to filter all the contents, then you might be able to do it. And that's what Facebook said they were going to do. I don't know if they did. Facebook and Twitter said they were going to have an army of people trying to remove all the bad stuff. Yeah.
ChatGPT, right?
Well, ChatGPT is the new one.
That's what.
Right. ChatGPT is the new AI system, and maybe it will be able to block the bad stuff. Although right now ChatGPT is got some flaws, but still. That's right. If you could make it, that's what everybody wants. That's the attempt to make this box. If you could only make a box that would identify the bad stuff so you could block it, that would be awesome. But the things we have now work by keywords and rules, and they're not very effective. This is a very good question. All right. So you'll see this kind of stuff at websites. This site is secure. People like to say this. This is a foolish statement. Anybody in the business, there is no such thing as 100% security. You can never have it. Just like, physical security. You walk down the street. How do you know you are not going to get robbed or killed by somebody on the street? You don't know. That does happen sometimes. It's not very common. If you avoid certain neighborhoods, it might lower the chance, but the chance is not zero. No matter what you do, there's no perfect safety and there's no perfect security. So anybody that claims that doesn't know what they're doing. I argued with these guys. They didn't care. These guys claimed a few years ago to have a 100% secure voting system because they use blockchains. And I said, anybody that says this, they're an idiot. The whole security community will laugh at you. There is nothing ever anywhere that's 100% secure. You're lying. And I couldn't get them to admit that. But anyway, so here's what your textbook authors found. How many websites they've had serious vulnerabilities. And you see, it's a lot of them. 32-edge SQL injection, cross-site request forgery and cross-site scripting were in the 90s, and so on. This is from websites quite a few years old. Your book is getting a little old. But anyway, a lot of websites have vulnerabilities, and we'll talk about them, how to exploit them, and how to patch them. And that's the point of this course. And if you aren't familiar with these, that's fine. You're going to become familiar with all these as we go ahead. ShinVR was another one of these examples. There was an unauthenticated request that would allow anybody to download the whole database. And remember, I found one of these. There was a college in Texas where their Android app, or I think it was an Android app, where the alumni app downloaded the entire alumni database onto the phone all the time with no authentication. So you could get everybody's credit card numbers and everything. It was pretty awesome. I told them about it and they fixed it. That's one of the few times anybody ever fixed anything from my reports. But anyway, here's the point. You just send an unauthenticated request and you get all this data coming down from the server. And this is what burp looks like. You send a request. This is the contents of the request, where you just have a whole lot of headers, and at the bottom you have get, and a body is true. And then here's the reply with headers, and here's the information, and this is a large amount of data coming from the server, and these blacked out parts are the redactions where they don't want to publish people's personal data. Now, mobile applications on your phone, iOS and Android apps, are very much like web apps. They work almost entirely the same way, and OWASP is the company, is an organization of people that organize to to study web security. And they specify the top 10 risks for web apps, APIs, and mobile apps. And here, for example, are the mobile apps. I spent a long time researching hundreds of mobile apps, doing security audits on them. And here's what you see. Most of the flaws in mobile apps are not on the phone, they're on the server. So weak server-side controls, insecure data storage, insecure data protection. Lack of binary protections is the main one that affects the apps. And so I tested hundreds of apps for these vulnerabilities, and I tested the top 10 banks, insurance companies, and stockbrokers, and I found all of them to be vulnerable. And here's, for example, a lot of the top banks, they're all vulnerable, and the main vulnerability they have is that you can modify the app, and the modified app will still work. So I could distribute a Trojan app that will steal your password or your credit card number or something, and they don't protect them from that. There are protections, but they don't use them. At least they didn't, but this was getting to be a while ago. I did this in 2015. Anyway, just a lot of them are vulnerable, just like a lot of websites are vulnerable. A lot of mobile apps are vulnerable. Then I did a lot of analysis of college security, college websites, and I found a bunch of them have been compromised by PHP redirectors that were selling Viagra from inside the college website. A lot of them had exposed student or staff data, SQL injection, 55 of them, and I notified these guys, and they mostly didn't care, but some of them fixed it. Anyway, there's the core security problem. The users can send up data, and they can send any kind of data, and often that data is not what the developer expected to see, and they didn't think about what would happen if certain kinds of malicious data came in. You got parameters in requests, you got cookies, you got HTTP headers, and if you have controls on your website, like you design your HTML to only let a field contain a number less than 100, you can't trust that. That's your code that's running on the client's machine. They can override it. With burp, you can change the data. So you cannot trust client-side controls. Client-side controls are running on the user's browser, and they can control that. If you want to have some restrictions on a field, you have to restrict it on the server where you control it. This is the most common problem. Developers often do not understand what machine is running their code in web development. There's a web server scripts, there's scripts on the client, there's often several servers involved, and they don't really understand which server is processing this, is running this script, and they don't understand which parts of it are under the control of the user. And that's fundamentally what leads to all these problems. Developers need to assume all input is malicious, and if you want to test websites, you use burp. Burp is a proxy. Every signal you send to the web is intercepted and placed in burp, and you can modify it. So if you have a website that will only let you put in a number up to 10, you can catch it in burp and change the number to a higher number. It's not part of your browser. You change the data on the way out. So you bypass all the defenses. So you can change the price of an item. This is an old one. You're trying to buy something. If they get the price from the client instead of from the server, you can just change the price and perhaps buy it at a lower price. You can modify a token to get into another user's account. This is extremely common. Cookie theft. I did a whole bunch of tests on these. I found because I heard that Microsoft Office 365 reused tokens, and I found that about half the websites did. When I did this a few years ago, I found that my bank did. Wells Fargo or American Express did. So if you steal a cookie from somebody's machine, the cookie continues to work. And what I found for most websites is if I steal your cookie when you've logged in, when you log out, that cookie still works. If you change your password, the old cookie still works. There is nothing you can do but cancel your account and make a new account, which is pretty gruesome. Now, not all websites work that way, but when I tested them, about half of them had that problem. Anyway, you can perform SQL injection where you send typically an apostrophe in something in a search field, and it causes data to be misunderstood as code. Then you can feed in commands and execute those commands on the server. And the point of these are very common attacks, and none of these are stopped by SSL, also called TLS. People say a site is secure if it starts with HTTPS, and it has some security. Then the data is encrypted. So you know eavesdroppers in between you and the server can't read it. But the attacks that involve injecting malicious content still work. You put in your data with SQL injection attack, it encrypts it, sends it to the server, decrypts it, and has the effect. So HTTPS, even though it's called HTTP secure, it's only secure against some attacks, but a whole bunch of attacks still go through it because they rely on the data being misunderstood at the server after it gets there. And the only thing HTTPS does is protect the data in transit on the way there. So this is the fundamental problem, is that you have a lot of developers who don't really understand security, so they write code and they do not understand the vulnerabilities they're causing. People are defining custom things, they're rushing things to product, trying to get them to market quickly. It's easy to make a website, but hard to secure it, and things keep changing. And people constantly want more stuff faster with less staff. And of course, that means they cut corners. And people typically find example code somewhere like on GitHub or Stack Exchange. And they just copy that code and use it and don't really understand exactly how it works and what the consequences are. And now that we got ChatGPT, it can write code for you. And they blocked it already on Stack Exchange, saying people that generate answers to ChatGPT, it's very often wrong. And we're wasting a lot of time trying to patch it because ChatGPT doesn't understand what it's doing. It just makes something that looks about right. It knows what the paragraph should look like. It sort of does what you would do if you Google like the top 10 sites and sort of mix those together to create it. So it makes stuff that looks good, but often is not very good. Anyway, so this is the new security perimeter. Up until 2002, Microsoft's official recommendation is the way to protect your network is to have a firewall on the edge of your network. You have this trusted zone like inside this room with these machines mounted in here, and then you have a gateway to the internet, and you have one device protecting you from the internet there. And everything on the inside of that firewall is now safe. That was the old model, but that is no longer good enough at all. The problem is people have portable devices like these, and people are there is no secure barrier anymore. There's no protected, clean environment inside. You can't trust any of it. They can all be hacked. So now you have to determine your barriers all through your network. You have to draw a data flow diagram. There's a Microsoft tool to do this. And then you consider when the data passes from one area to another, and every time it passes, you consider what security boundaries are going to protect it. It is much more complicated than just having one firewall protect your enterprise. You break your network into zones, and you consider the traffic flowing from zone to zone. And what you're trying to get to, recommended by the US government now, is zero trust. Zero trust is the limit, where the idea is anytime any server gets a request, you don't trust it. You decide whether to trust it. You consider where it came from, does it seem to be formed correctly, and things like that. You have tests on everything and before you use it, and you consider how trustworthy it is. So in order to get there, you move towards that by breaking your network into zones and having tests and the traffic passing between the zones. All right, so attackers can also attack users. This is what cross-site scripting usually is. You put a malicious post on Facebook and it attacks other people, so you do not attack the company. You don't steal the company data, you attack other users by bouncing an attack off the company. That's another consideration. And by the way, in that case, the company is probably not liable for it. So they don't really care, so they don't do anything about it. So if you report cross-site scripting, people typically do nothing about it. Almost every website has it. Most people just don't care because they don't consider it to be their problem. But anyway, all right. And if people do get into your email, of course, then they can get in everything because they can do password resets, and those will typically email a token to you to reset the password. So that's how you get a complete breach. Anyway, some vulnerabilities are increasing. This is, I think, WordPress. And so there were a lot of vulnerabilities year by year, and they go down and down and down. The serious vulnerabilities get better. Operating systems are much better. Windows used to be very vulnerable back in the days of Windows 98, Windows XP, Windows NT. Now it's much stronger than it ever has been. So the code is improving over time, but the attackers are improving over time, so it's constantly evolving. Anyway, let's try a Kahoot. This is an online quiz just to wake people up. Let me get it going here. This is worth extra credit if you're in the top 3. And you don't need to do it, but if you do, you have a chance of winning 3 points, and it can add up. And the main thing is it stops people from falling asleep so much. So let me get logged in here. All right. And get rid of the ad. ahead and go to my favorites, and in here should be 129S, Chapter 1. There we go. There, so use a phone or a computer or something and go to kahoot.it and then put in that number and choose a name. Oh my. All right, good. Well, we got about 30 students, so good. We got 18 so far. Good. All right, yep, 26 on the Twitch. And it looks like about 10 in the room. Okay, so we could get up to 35 in principle, but not everybody chooses to do it. I'll give it a few more seconds. Oh, lost somebody. We wait a second to see if T comes back. Okay, let's go ahead. Okay, well, I'll wait a few more seconds. People are still coming in. Okay. By the way, I should mention, if you're connecting by Twitch, look at your Kahoot screen because there's a time delay on Twitch. So the questions will appear there before you hear my voice. The people in the room are fine, but the people remote would be at a disadvantage if they waited to hear my voice about the questions. All right. All right, so what makes Web 2 different than the earlier? Yep, user-submitted content. That's the new thing. All right. And by the way, they grade you on both accuracy and speed, so you can get 1,000 points on each question. I see somebody, Karen, is really fast. All right. So what attack does SSL stop? This is the one that stops. If you put yourself in the middle, which means you intercept the traffic, then you can't do anything because it's encrypted with a key you don't have. That's what HTTPS, which is SSL, stops. But all these other attacks, it cannot stop because they rely upon malformed data being misunderstood at the server. And protecting the data in transit does not stop them. All it does is stop this, eavesdroppers and man-in-the-middle attacks. All right, what's the most common vulnerability of websites? Cross-site scripting, all over the place. People don't even fix it when you tell them. It's ridiculous. These other ones they'll fix, but cross-site scripting is very common and people don't care about it very much. All right, what's the most important defense method? Just to protect like a home user. Yeah, that's right. Most people would say antivirus, but most experts say it's updates. Updates are your most important thing. Because putting in patches as they become available protects you because attacks follow right after the patch. This is generally what people say. This is their strongest defense is putting on regular updates. That's why everybody will always be nagging you, put on the updates, put on the updates. All right. Of course, the updates can break things, which is why people don't want to put them on too fast, but that's the hard part. That's I know who that is. And Hector looks like a real name. These are the winners. And Karen, okay. All right. So if those are not real names, you'll have to tell me your real name to get your points. But if they are, my brother will be able to figure out who you are. All right. Let me stop this recording and have a separate one.